Hey guys, I'm Manoj. Welcome to this chapter from the course C# and .NET for Beginners. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. In the previous chapter, we already have discussed about how to create alternative code paths using conditional statements. We have used various conditional statements in the previous chapter, and some of those are if statements, switch case statements, and ternary operator. In this chapter, we are going to discuss about loops and jumps. In the beginning, we are going to discuss some basics about loops. We will have a look at what are loops and what are some common sections when it comes to programming the loops. After this basic theory, we will move to iteration statements. Iteration statements are the statements which are used to create loops in C#. Later in this chapter, we will also have a quick overview of some jump statements. These statements can be used to unconditionally transfer the execution control from one point to another. Okay, let's get started. We already have seen this flowchart in previous chapter. This is a step-by-step set of instructions which can be used to decide if a number is even or odd. We converted this flowchart into C# code. We also tried to run this program for various inputs to ensure that program is running as expected. Every time we run the program, we could provide a single input and the program was printing if the number was even or odd. After displaying the output, program was exiting. So for trying another input, we had to run the program again. You must have seen this behavior. The question is, what can we do to run the program as long as user wants? The answer to this question is very simple. We can ask user if user wants to try another input, and then based on this input, program can decide whether it should repeat itself or not. Let's look at this flowchart now. This flowchart contains same steps from previous flowchart. The only difference here is the flowchart is not going to stop state after displaying the outcome. Instead of stop, we can add a condition statement here. This conditional step will ask user if user wants to try another input, and if user inputs yes, it means user wants to run the program again. That's why the flowchart will transfer the control to the beginning. If user inputs no, then it will mean that user wants to exit. In such case, flowchart will go to stopped state. This flowchart is explaining very core nature of the loop. A loop repeats set of instructions. Those instructions are repeated until some condition is true. The condition should always evaluate to a Boolean value. This condition can be a simple condition involving one single comparison operator, or it can involve any combination of comparison operators, conditional operators, and Boolean operators. By now, we have understood that loop contains two basic parts: the code that needs to be repeated and the condition which will decide whether code should be repeated further or not. There are two more sections that can be generally seen with the loops. An initializer section is the section where variables required for loop conditions are initialized. For example, we may want to print same text 10 times. In that case, we will need an integer variable to count number of iterations. This counter variable can be used in the loop condition to verify the number of repetitions are less than or equal to 10. Every repetition of the loop is called as an iteration. So if we want to print the text hello world 10 times, printing it first time is the first iteration. Printing it second time is the second iteration, and so on. At the end of each iteration, there may also be an iterator section. An iterator section can be used to perform some operations which are required to be done before evaluating condition for next iteration. If our program is trying to print the text hello world 10 times, then in each iteration, after displaying the text, we may want to increase the counter by 1. This is how the loop condition will know how many times the code segment has been repeated already. So in this section, we have seen what is a loop. We also have seen what are some basic parts when it comes to coding the loop. Now let's move on to the next section. In this section, we are going to have a look at iteration statements. The iteration statements are the statements which can be used to program the loop. There are 4 keywords which can be used for this purpose. Those keywords are while, for, do while, and for each. Let's have a look at these keywords one by one. Let's begin with while keyword. The code snippet on this slide shows the program to print hello world 10 times. The initializer section is the part where variable index is declared. It has also been initialized with the value 0. This variable is then used in the loop condition. The syntax for starting loop is the loop keyword while followed by the condition inside parentheses. So here we are saying repeat while index is less than 10. After this condition, we can add the code that we want to repeat inside the curly brackets. The code inside the curly brackets is called as body of the loop. Let's say if the loop body contains a single line of code, then the curly brackets can be avoided. Now let's see how this loop executes. Firstly, the variable is initialized, and then the control comes to next line where condition is evaluated. If the condition is true, then the control starts executing the body of loop. The loop body may contain any statements like arithmetic statements, string operations, or method calls. At the end of iteration, the index is incremented by 1. We have used a plus plus symbol here. This symbol is called as post increment operator. It increases the value of its operand by 1. After the iterator statement, the condition is evaluated again, and this goes on until the condition is evaluated to be false. When the condition is false, the loop terminates and the control executes the next statement after the loop. The initializer section here is very obvious. There is no chance of missing it because it declares the variable that we should use in the loop condition. But if you are a beginner, then there is a slight chance that you may miss the iterator section. So in case of this program, what will happen if the iterator section is missed? If the counter is not incremented at the end of every iteration, then loop condition will never know how many times the code has been repeated. And this will result in condition always being true, regardless of how many repetitions have been done already, because the counter will always be 0, and this will cause an infinite loop. Now, let's talk about the for keyword. If we use for keyword, then all the three sections, initializer, condition, and iterator, can be specified in the single line as shown here. After this, the loop body can be specified within curly brackets. If the loop body contains a single line of code, then the curly brackets are not required, but it is better to use curly brackets to explicitly mark the boundaries. Let's now see how the code is executed. Firstly, the initializer section is executed. After the initializer, the condition is evaluated. If the condition is true, then the code block inside the curly brackets is executed. Once a single iteration is done, the control goes to iterator part of the for statement. In this code snippet, the iterator part increases the value of index by 1 using post increment operator. After iterator statement, the condition is evaluated again, and the flow continues like this until the condition is false. When the condition is false, the next statement after the loop is executed. The important point to note here is all the three parts that we specify in the for statement are optional. So initializer, condition, and iterator are optional and they can be empty. For that matter, we can just specify 2 semicolon inside the parenthesis after for keyword. This would mean that the loop is infinite. There is no condition to break the loop and the loop will execute endlessly. Till now, we have seen the code examples where the iterator section increments the value of loop variable by 1 using post increment operator. Similarly, there is a post decrement operator as well. It is represented by double minus signs. It can be used to decrement the value of its operand by 1. Instead of increment or decrement, an iterator section may contain only assignment statement. This assignment statement will just assign some value to the variable which is used in condition. Okay, let's move on to the next type of loop. The next type of loop is a do-while loop. This loop is little odd as compared to previous two loops. The syntax of do-while loop is very similar to syntax of while loop. Before beginning the body of loop, there is one initializer section to initialize the index variable. And then there is a while keyword followed by the condition. But the difference here is the body of loop comes before the condition. The body of loop begins with the do keyword. Do keyword is followed by curly brackets, and inside these curly brackets we can specify the statements that we want to repeat. After the curly brackets, we can use while keyword followed by condition inside the parenthesis as shown here. Here, the flow of execution is bit different. After initializer, the body of loop is executed even before evaluating the condition. That's why this loop is bit odd. The condition is evaluated after the code block has executed once. If this condition is found to be true, then the loop body executes again. This flow goes on like this until the while condition is false. Let's compare the do-while loop with the while loop. Let's say we initialize this index variable to a value 10. In such case, the loop condition will evaluate to false. In case of while loop, the loop body will not be executed at all because the condition is false. On the other hand, the do-while loop evaluates the condition at the end after the first iteration is done. That means the hello world text would be displayed once and then the condition would be evaluated. And as the condition would evaluate to false, the loop body will not execute again and the loop will terminate. That's why do-while loop is bit odd. The while loop and the for loop evaluate the condition. That means they will repeat set of instructions 0 or more times. On the other hand, the do while loop will execute the body one or more times. I hope the difference is clear now. Let's move on to the next type of loop. The next type of iteration statement is for each loop. The for each keyword provides an easy way to iterate over a collection. A collection is an object which stores multiple values. So for demonstrating for each loop usage, we have created an integer array here. This first line is the syntax to create an integer array. Int keyword is followed by square brackets, followed by the variable name, and variable name is followed by an assignment operator. The square brackets specified on the right side of assignment operator contains a number. This number specifies how many values this array can hold. In our case, we want to store 5 values in this array, and that's why we have specified the number 5 inside the square bracket. After the square brackets, an array can be initialized by specifying 5 values inside curly brackets. We have not covered the collection data types yet in our course. We will try to cover collections in future chapter. Okay, so we have declared an array. Now, because array is a collection type, we can use it inside the for each statement. The for each statement is easy to read. It literally says for each number in array. Here, the number is a variable which represents a single value from the collection. As number is a variable, it will also need a data type. We can use var here and let the compiler deduce the data type automatically from the collection, or else we can explicitly specify the data type here. So here, in this case, we could have used int instead of var, and the program would still work as expected. Inside the body of for each loop, we can add one or more statements. If for each loop contains a single statement in the loop body, the curly brackets here are not mandatory, but it is better to add curly brackets to explicitly mark the boundaries. As you can see here, we have not used any iterator or initializer as such. The only requirement for using for each statement is there should be a collection object, and the data type of that collection object should have implemented getEnumerator method. We will talk more about this method and for each loop when we discuss about collections. This concludes the theory part of the chapter. Now, let's use this theory to write some code. Let's open the Visual Studio and create a console application. In the last chapter, we wrote a program to identify if given input integer is even or odd. I am going to write that program again. So, a console.write to ask for user input, and then console.readline to read the user input, and convert.toInt32 to convert that input value into integer. After this, we can use a ternary operator to check if remainder after dividing the number by 2 is equal to 0 or not. If it is 0, then ternary operator would return text even. If it is not, then the ternary operator would return the text odd. Next, we can use the outcome of the ternary operator into a console.writeLine statement to print the output of the program. It seems our program is ready, but if we run the program now, the program will only work for single input and then program will exit. If we want to try any other number, we will have to run the program again. Let's try to modify this program to keep it running until user wants it to run. The idea here is to ask user if user wish to try another number. If user enters y, then the program will keep running. In this case, our condition will be based on a single character. So in the initializer, let's declare a character variable keep running and assign a value y to it. Why did we assign this value to the variable? This is because when the program runs, we want it to start with asking for integer input. It need not ask whether user wants to try another number. So after initializer, we need to set the loop condition. Here we will use while loop. In the loop condition, we can say that while keep running is equal to y, run the body of the loop. Here we are using double equal to sign, which is equality comparison operator. So we have initializer ready. We also have set the condition, and we have an empty body in the loop. So I will move rest of the statements inside the body of loop. Now the last part is iterator section. Here, let's add a console.write to ask the question if user wants to try any other input. After displaying the text, let's add console.readKey, which reads a single character input and it does not wait for user to press the enter key. The return value of console.readKey is console keyInfo object. This object has a property keychar. This property returns the input character. So we can assign input value.keychar to keep running variable. Now iterator section is also done. After the loop body, we can add a goodbye message. So let's add a console.writeLine to display have a nice day text. This is to confirm that program is exiting. This text will be printed if user enters any value other than y. Also, in the iterator section, we have used console.write. And as we know, console.write does not actually print a new line. Let me add a console.writeLine to ensure that subsequent text is printed on the next line. It seems our program is ready. Now is the time to verify if it runs as expected. So let's run the program. We can enter 10 now and the program correctly prints that the number is even. It also asks if we want to try any other number. Let's press lowercase y here and the program will ask for another number. We can try 13 and it correctly prints that the number is odd. Next time, enter any value other than y and the program will exit. While exiting, it displays the goodbye text to confirm that program is exiting. So it seems like our program is working as expected. But this program has a flaw. The loop condition only checks for lowercase y. What if user enters uppercase y? Let's run the program again and this time try any random input. And when program asks if we want to try any other number, let's enter uppercase y. Surprisingly, the program exits. Why did it exit? A character is internally an integer value. A lowercase letter has different integer value than the corresponding uppercase letter. That means the value of lowercase y is not equal to the value of uppercase y. Now what can we do to fix this behavior? We can modify the loop condition and use a conditional or operator here. So let's modify this condition and let's say until keep running is equal to lowercase y or keep running is equal to uppercase y. We want loop to run. After this modification, let's run the program again. Try any random input. And when the program asks if we want to try any other number, let's enter uppercase y. In this case, program doesn't exit. It asks for another number. So seems like our fix is working. Now let's see how this same code can be converted to use a for loop instead of a while loop. In the for statement, the initializer, the condition and the iterator can be written on the same line. In our case, let's add initializer and the condition in the for statement. Now the iterator section is a bit tricky. We have an option to move this line where we set keep running variable to the input value in the iterator section. But in my opinion, that may reduce readability of the code. So let's keep this iterator part empty. We already know that all the three parts of for statement are optional. That's why the for statement will allow this syntax. Just to clarify, we have not skipped the iterator section. In our case, the iterator still exists, but it is inside the body of the loop. Let's try to run the program. Enter, let's say 10 as input. The program correctly displays that the number is even and then it asks if we want to try another input. Let's enter y and the program will ask for next input. Now let's say we enter 13 and program will correctly print that it is an odd number, and after that let's enter n to exit the program. It seems our loop is working as expected. Now let's try to convert the same program to use a do while statement. Firstly, let's move this initializer at the beginning. As we know, the do while statement executes the loop one or more times. That's why we don't need to initialize keep running variable to value y. This is because when the loop executes for the first time, it will not check if the keep running variable is equal to y or not. It will first ask for the input number and then the while condition will be executed. So our initializer is done. Now instead of for, let's type the keyword do and copy this condition from the for statement and let's go to the ending curly bracket of the loop. Here we can type while keyword and then we can specify the same condition inside the parenthesis. The closing parenthesis will be followed by a semicolon and that's it. The rest of code can stay same as it was before. Now, if we run the program, it should produce the same outcome as expected. So in this section, we have used different kinds of iteration statements to create the loops. I hope this was helpful for you to understand the differences between these three types of loops. Okay, let's move on to the next example. In previous code example, we have used single loop. We can also nest the loops. This means that one loop can be present inside body of another loop. For demonstrating that, let's try another problem statement. When we were in school, we have studied multiplication tables. Let's write a program to print multiplication tables for numbers from 11 to 20. We will display the multiplication tables in the format as shown here. Here, the tables are shown side by side, but in our code, they will be printed one after the other to keep the things simple. So for our program, each number from 11 to 20 must be multiplied by each number from 1 to 10. We can achieve this by using nested loops. We can have an outer loop variable which represents the current multiplication table, and then we can have an inner loop variable which represents multiplier from 1 to 10. Let's begin with for statement. In the initializer section, let's declare a variable index. Let's initialize its value to 11. And in the condition section, we can specify that we want to run this loop until the value of this index variable is less than or equal to 20. In the iterator section, we can increment the value of this index variable by 1. So this is our outer loop. Inside this loop, we can add some marker statements to represent beginning of the multiplication table for a number. So let's add 3 console.writeLine statements as shown here. The middle statement displays the header for the current table. Next, we need to multiply the value of this index by each number from 1 to 10. So, begin another loop. In this nested for loop, we can begin with initializer section. Let's declare a variable called as multiplier, which is initialized to value 1. And here we can specify the condition that this nested loop should continue for all the values of multiplier until multiplier is less than or equal to 10. And finally, in the iterator section, increment this multiplier by 1. Okay, so we have defined two loops, one inside the other. Every iteration of outer loop will execute all the iterations of inner loop. That means for 11, inner loop will execute 10 times. For 12 as well, the inner loop will execute for 10 times, and so on. Every iteration of inner loop will have both the values, index and multiplier. We can multiply those two numbers and then display the result in the intended format like this. Here, we are printing the value of index, the value of multiplier, followed by the result of multiplication. Now, if we run the program, we can see that the multiplication chart is printed one after the other. I hope this demo was useful to understand how nested loops work. Although this code example had a single level of nesting, technically any number of loops can be nested, one inside the body of the other loop. Okay, let's move on. Jump statements are the statements which unconditionally transfer the control from one place to another. We are going to have a look at 4 keywords in this section. Let's start with keyword goto. As the name suggests, it instructs the control to go to a specific label in the code. A label is just an identifier followed by a colon as shown on this slide. Here, the code snippet is showing the usage of goto statement. It is trying to print the text hello world 10 times using goto statement. In this code snippet, there is initializer which initializes the index variable to 0, and then there is a label of name repeat_label. The label is followed by the colon character. After the label, there is a single statement to print hello world. And then there is the iterator statement to increase the value of index variable. On the next line, the conditional statements verifies if the value of index variable is less than 10. And if it is, then the control is transferred to the repeat label using goto statement. The syntax of goto statement is very simple. The keyword goto followed by the label name, repeat_label. After the label name, there is a semicolon to end the statement. In this code snippet, the goto statement produces the same effect as that of loops. In general, the code which uses goto statement may not be easy to read, and that's why it is general practice to avoid usage of goto statements. In all the cases, the code which uses goto statement can be rewritten without using the goto statements. For example, in this code snippet, we could have used any iteration statement to produce the same outcome. Let's now move on to the next keyword. The next keyword is break. We already have used this break keyword inside the switch statement. In the switch statements, this keyword was marking end of section for a particular case. In loops, the break keyword can be used to terminate the closest loop. Every loop statement contains condition. If that condition is false, the loop is terminated. But sometimes we may want to terminate the loop even before all the iterations are done. This is because the code might already have got the required result. In such cases, we can use break statement to terminate the loop. It will only terminate the closest loop. So let's say the loops are nested and one loop is inside the body of another loop statement and the break statement is inside the inner loop. Then the break statement will terminate only the nested loop. The outer loop would still continue executing. Here the code snippet shows the code which terminates the loop when index is equal to 5. This means the loop will display the text hello world 5 times. In the 6th iteration, index will be equal to 5 and that's why the if condition will become true. And in that case, the loop will be terminated because of the break statement. I hope this clarifies the meaning of break statement. Let's now move on to the next keyword. The next keyword is continue keyword. This keyword is used inside the iteration statements. When the continue statement is executed, all the subsequent code statements which come after the continue statement are skipped in that particular iteration and the loop begins next iteration. The code snippet shown here prints hello world in first 5 iterations. In the 6th iteration, the index will be equal to 5 and hence the continue statement will execute. This will cause skipping of rest of the block of code. This means the text hello world will not be displayed when index is equal to 5. Let's move on to the last keyword of this section, and the keyword is return. In C#, code inside a class is organized into multiple methods. Each method may call another method. So there can be first method which calls second method, and this second method may call some other method, and so on. The return statement terminates the closest method and returns the control to its caller. If the return type of a method is void, then the syntax is just the return keyword followed by the semicolon. But if the return type of a method is not void, and if the method is supposed to return value of any specific type, in that case, the return keyword will be followed by a variable of that type, or it can also be followed by a value which can be assigned to that particular type. We will again discuss this keyword when we talk about methods in coming chapters. Let's try to understand this code snippet a bit. Here, we have declared a method with name display hello world. This method contains a loop. Inside the body of the loop, there is a condition to check if index is equal to 5. If the index is found to be 5, then the return statement will be executed. This method is called from the top level statement. So, when this code is executed, the text hello world will be printed for 5 times. In the 6th iteration, the index will be equal to 5 and the control will return to the caller. This also means that the loop will be terminated. Okay, let's move on. Now again, it is time for us to open Visual Studio and try these jump statements in our code. Let's write a program to check if a string is palindrome or not. A palindrome is a word, number, phrase or other sequence of characters which reads the same backward as well as forward. For example, words like radar, level, civic remain same even if the order of letters is reversed. Thus, they are palindrome. For identifying if a string is palindrome or not, we can write a loop. We would need two variables, one moving forward from beginning towards the end of the string, while the other moving backward from the end of the string towards the beginning. In every iteration of the loop, we can check if the characters pointed by the two pointers are equal or not. If the characters match, then the loop will continue. This comparison will go on until the two pointers cross each other. There is also one more case in which the loop may terminate. If the two characters pointed by forward pointer and the backward pointers are not matching, then we can terminate the loop by using break statement. Let's begin writing our program. Let's ask user to enter a string. Then we can use console.readLine to read the input. The user input may contain uppercase as well as lowercase characters. We will use .toLower method on the input string variable, which will transform all the uppercase alphabets to lowercase. This step will help us avoid some additional conditions while comparing the characters. A string is basically a sequence of characters. The first character of the string is present at index 0. A string variable has a length property which represents the length of given string. The number string.length -1 represents the index of last character in that particular string. Now we can declare two int variables, forward and backward. The forward can be initialized to 0 and backward can be initialized to input string.length -1. We are going to refer these variables as pointers. This is because each one of them is pointing to a specific character in the string. We could have specified both these variables in the initializer section of the for statement. In that case, those two statements would have been separated by comma, but for the sake of this demo, we will add an empty initializer section in the for statement. In the condition section, we can specify that the forward pointer should be less than or equal to backward pointer. If forward pointer is greater than backward pointer, this means the two pointers have crossed each other and that's why the loop should be terminated. Now in the iterator section of the statement, increment the forward pointer by using post increment operator and decrement the backward pointer by using post decrement operator. These two statements can be separated by comma as shown here. Inside the body of loop, we can compare the two characters pointed by these two pointers using the if statement. If those values do not match, then we can write a break statement to terminate the loop. Otherwise, the loop will continue to execute until the loop condition is true. The loop may get terminated because of two possibilities. Either the string is palindrome, in which case forward pointer will be greater than the backward pointer, while on the other hand, if the string is not palindrome, then the forward pointer wouldn't have crossed the backward pointer. After the loop, we can use ternary operator to see if forward pointer is greater than the backward pointer. If it is the case, then the string is palindrome. Otherwise, the string is not palindrome. So we can use a ternary operator like this, which returns a string value. This outcome of ternary operator can be then used in a console.writeLine to display the outcome of the program. Okay, it seems our program is ready. Let's try to run the program. First, let's try with a string which is palindrome and the program correctly identifies that the string is palindrome. We can run the program again and this time we can input a string which is not palindrome. This time also program correctly prints the output. So in this code example, we have seen how to specify multiple statements in the initializer and iterator sections of the for loop. I hope this example was also helpful to understand how the break statement works. Now, let's move on to the next example. This time, we are going to write a program which allows user to input an integer value. The program will check if the number is prime or not. If the input number is not prime, then the program will ask user to input the next number. That means user will exit the program only if the input number is prime. So let's begin the program by asking user to input an integer value, and then we will use console.readline to read the input. After that, convert.toInt32 can be used to convert the input into integer. Now we have the input number. Next, we need to check if this number is prime or not. A number is prime if it is divisible by 1 or the number itself. That means if the number has any other divisor, it would not be prime. So we can take a loop here. The loop will range from all the values starting from 2 until number -1. And if any value divides the input number, then the input number is not prime. So let's add a for statement in our code. In the initializer section, let's take variable I and initialize it to 2. In the condition section, let's write a condition that I should be less than the number. Remember that condition is evaluated before executing the body of loop. So the body of loop will be executed only until I is equal to number -1. When I is equal to number, the loop will terminate. In iterator section, we can increment I by 1 using a post increment operator. Inside the body of loop, we can use modulus operator to check if the remainder is 0 after dividing the number by I. If the remainder is 0, it means the number is divisible by I. That means the number is not prime. And in that case, we don't need to continue the loop. We can add a break statement inside this if block as shown here. If the remainder is not 0, then this loop will keep executing. Outside this loop, ternary operator can check if I is equal to number. But wait, here we are getting an error. If I hover over the red line, I can see the details of the error. It says that variable I does not exist in the current context. We have not discussed variable scopes yet, but the variable scope is the area in which the variable can be accessed. We will discuss more about scopes in some future chapter. For simplicity, we can assume that the scope begins with opening curly bracket and it ends with a closing curly bracket. So if we declare a variable, it would be accessible only before the next immediate closing curly bracket is encountered. So here we got to know that if we declare a variable in the initializer section of the for statement, it cannot be used outside the body of loop. The body of the for loop is the only allowed context or scope for using that variable. So let's change our loop a bit. Let's move this initializer before the loop. So now the variable declaration of I is a top level statement. That means this variable will be accessible from both inside as well as outside of the loop. Okay, now coming back to where I was. We can add a ternary operator here to check if I is equal to number. If it is, that means all the iterations of the loop were executed, no other divisor was found. So the number is prime. And that's why the ternary operator would return the text prime in that case. If this condition is false, that means other divisor was found and the ternary operator will return not prime text. Now we can add a console.writeLine to print the end result on the console. We know that this program handles one input at a time. The program will exit after checking if a number is prime or not. We will need to run this program again for trying any other input. So let's modify our program and use a goto statement this time. Let's add an if statement like this. Here we are checking that the number should not be equal to I. This condition will be true when the number is not prime. Now inside this if block, we can use a goto keyword followed by a label name, beginning. Currently we don't have any labels inside our code, so we will have to declare a label with name beginning. For that, let's go to the top of the program and then type the identifier name beginning followed by the colon character. Now our program is complete. Let's try to run the program. We can try any numbers as input. If the input number is not prime, the program will keep asking for next number. If the input number is prime, then the program will exit. In this code example, we have seen how to use goto statement. Again, we could have used iteration statement to produce the same outcome as goto statement. In my opinion, it is always better to avoid goto statement as it reduces the readability of the code. Okay, let's move on to the next example. In the next code example, we will try to write another program to display sum of all those numbers between 1 and 200 which are divisible by 8. So let's declare a sum variable and initialize it to 0. Then we can write a for statement, and in the initializer we can take a variable number and set it to 1. Until this number is less than or equal to 200, increase the number by 1. Okay, our loop definition is ready. If the number is divisible by 8, then we need to add it to some variable. So we can use an if statement. The condition for if statement can use a modulus operator to check if the number is divisible by 8. When the number is divisible by 8, the remainder would be equal to 0 and hence the condition will be true. Inside this if block, we can say that sum is equal to sum plus current number. If the current number is not divisible by 8, then the remainder would not be equal to 0 and the if condition will be false, and that's why if block will not execute. Our program is ready. We can run the program and see the outcome. Now coming back to the code, the loop was keeping all the numbers which were not divisible by 8. Let's modify this program to understand how the continue work. For that, we will have to change the if condition. The new condition should check that remainder should not be equal to 0. When this condition is true, we want loop to skip all the rest of the statements in the body of loop. So we will add a continue statement here, followed by a semicolon. If this condition is false, that means the number will be divisible by 8, so the iteration will not be skipped. In that case, outside the if block, but inside the for loop, we can add a statement to add the current number to current value of sum. Okay, our program is ready. Let's run the program and we can see that the same outcome is produced by the program. This was our last code example. I hope these code examples were helpful. Now let's move on to the final section of this chapter. This section shows exercises that you should try on your own. In the first exercise, ask user for integer input and then calculate the factorial of that number. A factorial of input number can be calculated by multiplying all the positive numbers which are less than or equal to the input number. In the second exercise, allow user to provide as many numbers as user wants. Once user is done providing the numbers, print the smallest number and the biggest number. In the third exercise, ask user to input an integer, then reverse the digit of that number. For example, if user enters 1, 2, 3, then the output should be 3, 2, 1. Here, we do not need to perform string operations. Try to convert the input number to integer and then use modulus operator and division operator. In fourth exercise, write a program to print the sum of all those integers which are between 100 and 200 and which are also divisible by 6. Let me know the outcome in the comments. Alright guys, that's it from this chapter. Thanks for watching. If you found this content helpful, like this video and subscribe to the channel. If you have any feedback or suggestions, please let me know via comments. Alright, see you in the next chapter. Namaste.